Alright everyone, here's the situation. Dog is super stressed out. We just had a crazy storm go by, knocked the power out. He's got a little anxiety. Well anyway, we're in this project house over here. I've been spending about half my nights living here, which is why I've got a bunch of unpacked boxes and things look a total mess. But 100%, this is a project house. You know, glass is busted out. We tore out the kitchen just recently, ordered cabinets. You know, this is not a place where you're used to all of the standard amenities. However, we do need power. We need to run the air conditioner. It's pretty freaking hot and humid. And we need to keep our food in the fridge fresh, right around the corner here. So, some of us might be thinking to ourselves, man, I really wish that I had bought that solar system 3 years ago when I was thinking about it. That's exactly what my thought was as soon as the power went out. The reason being, I have a friend about 3/4 of a mile away. Her power's out. I've got another property just down the street from there. Power's out there. And my boss is about 15 miles away and his power's out. They had 80-mile-an-hour gusts. He has storm damage to his house. I think that based on the scale of where the power's out across the city, this might be a while. Luckily, I happen to have a mid-sized solar system, at least the bare components, right here in this house. So, I've got a MPP solar LV2424. I've not hooked up any of this stuff. However, I do have 2 BYD battery packs. These are industrial solar farm batteries that are used. When they're new, they have 5.6 kilowatt hours each. I have not tested these, so I don't know what they have. However, I can use one of them to run a simple system, to run an air conditioner and the refrigerator, at least for a little while. I've got all the cables, the tools, the seals, absolutely everything to make this whole system. Not house-tied, just a small standalone system, something capable of running medium-sized loads. I've got these Ant BMS modules. These are the ones everyone's all giddy about at the moment. I've got one for each battery. These are the quote-unquote 320 amp versions. Don't hold your breath on that. However, the functionality is supposed to be very nice. I don't have the balance lead connection. There's a converter piece that I need to get from Tech Direct Club, and I don't have that yet. But anyway, I'll have everything else that I can use to create basic functionality, and we're going to see what we can do about that, because just in the last hour since the power went out, it's come up in here easily 10 degrees. So we're going to put a little project together. I'm going to take you along for the ride. I don't know what we're going to call it. Send Relief, Des Moines, Iowa, 2020. COVID sucks. Dog anxiety. Whatever you want to call this. We're going to have fun with it. First things first, we got to figure out how we can get power out of and back into these batteries. The terminals on here, I don't remember what they're called. It's like quick lock or something. It's very specific to a kind of industrial application, and the connectors are like $40 each. They're usually for larger cables also than what we would really use in this application. So what a lot of people are doing is making their own terminals. I thought I would cheap out and get a quick fix. Someone suggested that a 4-aught ring terminal would actually fit on here. That is not true. That just doesn't fit. Just for your reference for later, let's see what these actually do measure. See, even the lugs I ordered were advertised as being 14 millimeter, and then this end piece is 11.9. So, the main lug here is 14. This little nipple here is 11.9 millimeters. So, as an alternative, because I always got a plan B, I followed the instruction of David Paws, I believe is how you say his name. This is some 1/2 inch just copper tubing you can get at the hardware store. You want to make sure you get the one with the blue lettering. That'll be type L. It has a slightly larger inside diameter, which is important here. And David actually had to put a slit down the end of his to get it to spread over the terminal. I can actually see here with just a little bit of twisting actually slides right over mine, and there's enough friction there. I mean, I'm giving it a tug right now. There's enough friction there you can actually rely on some current. So what I'm going to do is not modify this, and I'm actually going to just clean it up a little bit with a deburring tool that goes on a drill. This is for 3/4 inch pipe. I gotta find mine for 1/2 inch pipe. But all you do is put this on a drill, and you put the brush down into the opening of your pipe, put the pipe into the plastic housing. You see there's bristle action going on there too. And then you just run your drill on it, just kind of back and forth, just quickly, and it'll clean this copper up really well. So once I find my 1/2 inch, I'll do that. For now, just for today, because it needs some power, we're going to skip that. But I wanted you to see this is the very cheap way. I think I got this for like $3. Very cheap way to make terminals. So what I'm going to do is just cut off sections of this and flatten one end, drill a hole for making basically a ring terminal out of copper, and that's what we're going to do. Alright, so the next thing to do is going to flatten out this metal pipe. I don't have a vise, unfortunately, and since we keep it real in these streets in DSM, we're just going to use some vise grips, and I'm just going to show you the first step here. So you can see if I squeeze down on this, the pipe deforms just a tiny bit. I don't know if you can see it there. Yeah, you can see it a bit. So I'm just going to do that, and then turn the little adjustment wheel on here a little bit, and come back and just keep doing that over and over again until I get a nice flat terminal. So I'll be back. Using the vice grip to flatten this was working. It's okay, but it'll give your hand a workout, that's for sure. And I'm noticing that I'm getting a crease in the middle here, right there. So I imagine this is going to split if I keep doing what I'm doing. So I'm actually going to take this outside on some concrete, and I don't have my sledge here, so I'm going to try to use this 16-ounce contractor's hammer and see what we can do. Got a decent finished product here, actually. It's a little marked up from the pavement or concrete, but it's pretty flat, and I think I can clean it up with a little whiz wheel and it'll look nice. Well, our flat ends look pretty good, and I'll clean them up with some sandpaper, but you can see, even with being very careful on the other side not to apply too much pressure with pliers, just pulling on the copper actually deforms the other end. So it may be that it would be best to do this while the terminals are actually on the batteries. I don't think these are actually going to fit back on there without a little excessive force. Well, in true I need it now fashion, I can't find the tool I was looking for, but we're going to use that deburring tool that I mentioned earlier, and we're going to try to clean this up using a big powerful drill on the fast setting. So let's see what we can get. Start with this side. Not bad. So I'll just do that to all 4 pieces. In an ideal world it would be a little cleaner, but that's not what we have today, so you can make it work. As we talked about briefly, even when being careful, deforming one end of a short piece of metal will deform the other end. I haven't tried this yet, but I expect not going to go on there like it did before. So I'm going to try something. So what I've done, I've used my vice grips to try to compress this on the oblong to try to bring it back to circular. It's not perfect, but let's see what we get. I might get lucky here. How about if we apply a little bit from the dead blow hammer? Nope. Alright. As you know, this video is being made on the fly. I don't have a proper camera set up or something to hold my phone, so you're going to sit on top of some paper towels for a minute. This is our 1/0 cable. It's going to be right into the inverter. This is just showing the gold-plated ring terminal. You just want to put your sheath on there. If you have rubber or silicone like this, that's good. If not, you want to make sure your heat sink is in place before you terminate this. Kind of mark out where you want to remove the insulation. I'm going to say right here at the beginning of this E, This tool, I've not loved it so far. I've only tinkered with it so far, but we'll see how it does. So try to target where you need your terminal to sit. Or I guess how much insulation you need to take off for that to happen. It just sits in there. There we go. Sits in there. And you ring it around. And it should peel off, but you have to adjust the length or the depth a little bit. To adjust the depth, screwdriver and this flat bit at the end, and you turn this. Let me try it again. This is the problem I've had with this tool. It walks. It doesn't stay in one place on the cable. So it doesn't matter if you penetrate all the way through, because you're not getting your end point meeting your starting point. So I try to push one way a little bit as I'm using this thing. Like I said, I really had high hopes for this tool, and it's not quite there. But we'll see what we get. See this? I'm just gonna use a razor blade. Utility knife disassembled, blade removed, this junk. So we're just gonna go old school with this. You do need to apply some pressure. Just push directly against the cable. Make sure that your finger is out of the line of sight of the blade. I mean, this all might sound really simple, but accidents happen literally all the time. So just don't put yourself in the way. Just gonna use this flat blade to tear what little membrane is left. And there we have our nice exposed conductor. Alright, we're outside. We're going to try our hammer crimper. I noticed when I was inside, I had the red boot on the black cable. I'm sure you guys noticed that too. I'm a little disappointed you guys didn't say anything about it and give me a heads up. You just waited to see what would happen. Well, I noticed. I fixed it. And we're going to try out this hammer crimper. I never tried one of these before. Basically just slide this mechanism up. You put your various size large cable in there, smack the hell out of it with a hammer. I've got my dead blow again, so we'll see how it goes. Well, not successful. So I tried it again with the other cable. Didn't work quite as I had hoped. This lower piece here folded under. I ended up getting a decent crimp at the end down here. Then I came back with the tool again and just tried to shape it so that the boot will slip over it. Just didn't execute the way that I had really hoped. Again, far from perfect. I'm definitely disappointed in what I'm getting out of this, and a lot of people have a lot of success with these. I'm pretty disappointed with that. But it is what it is for today. We don't have a lot of options. I didn't get any extra ring terminals because I thought it would go a lot easier than that. So now that we've got our ugly crimps, I want to show you I did clean up the extra strands that were sticking out. It does pass the pull test, so it should pass the maximum of 100 amps that we're going to have going through this system. If I get an opportunity later, I will buy another cable and another ring terminal, or 2 or 3, and go back and redo this. Again, I'm not real happy with it, but it is what it is for today. So you just want to slide these sheaths. Like I said, these are like a rubber or silicone from New Concepts, but if you just have heat shrink or something, just make sure that you've applied it to the cable before you actually crimp your ring terminal on. And putting this protection on here will prevent you from accidentally grounding these out to each other or anything else when you go to put them on your distribution blocks or whatever you've got. Alright, so I'm just going to build up my distribution blocks here with a cover on it. This one is the one on the power side, so I've got a fuse for each of these locations. I'm putting it in behind the washer, between the block and the washer. I don't know if there's another way to do it that would be supposedly better. For me, I'm just interested in the most contact surface as possible. I'm using a 3/16 Allen wrench. It's a little bit loose, so in reality these might be 5mm metric bolts. I'm not real sure. 3/16 seems to handle it. I'm just not torquing it excessively. Putting in the other one, and the other distribution block, which is for my ground side, you assemble the same way. The only difference being you use these flat bar links instead of fuses. So you've got your assembly there, put in your cable, bolt in from the side. Once you've done that on all the applications, go ahead and snap your cover back on there, and you've got, pretty inexpensive fused bus system. A word of caution with these fused distribution blocks here. The thread on these bolts is super small. I don't know if you can see it in there. Super small. And this one actually stripped out with almost no effort at all. So I actually removed the thick washer that came with the setup. You can see the thick washer here. And I took just a blue ring terminal, cut the circular head off of it, and use that thinner washer instead so I can get down to some good threads in here. But be careful with these things. That stripped out way easier than I expected. Also, the terminal on the side here, this is not 3/16. This is actually going to be 5/32. So you need 2 Allen wrenches to work these. Well, I decided that since we're going through all this trouble, we might as well try to rig up both batteries so we have twice the capacity. As mentioned before, I don't have one of the adapters I'd like to have in order to hook up the BMS modules. However, or BMS, I guess, for each one, I still like to run them for a little while. So what I've done here is put the 2 batteries in parallel so that one will be at a higher state of charge and then discharge into the other, so that when you connect them directly with no load between them, they're not just going to short circuit from one to the other. And what that means is, high voltage flows to low voltage. If they're not perfectly at the same voltage level, one of them is going to have 0 resistance and just dump as much energy as possible. It's not good for either battery, and it's potentially dangerous. So what I've got here, just using what I've got, some wood clamps and a masonry bit connecting the negative terminals there. On the other side, I've got a paddle bit going down to a 1 ohm 100 watt resistor, and just a couple of wood clamps holding that positive side together. I should have done this before. Usually you'd want this to sit for 12 or 24 hours. So I don't know really how well these were matched before, but what I've done as a little test is broken this circuit. So here they are not loaded from one to the other anymore through this resistor. So I've got an open circuit. I've got my Fluke 87.5. So we're just going to do a quick current draw test. We're now completing the circuit using the meter. And we see we've only got like 20 milliamps of current moving. So we know we've got a complete circuit. That's good, especially considering because we've got such a janky setup here. But we know that the batteries are extremely similar in charge, or at least in voltage, because the current draw is almost nothing. So I'm going to let this sit just like this for a while I move on to other parts of the project. And you want to make sure your batteries are at the exact same voltage, not just what you read on a meter, but literally put them together with a low impedance load and just let them sit. So that's really important. What I've done, we've got our 1 aught power and ground going to these distribution blocks we've assembled. I've now cut 1 foot off of the black and red cable that I've got. This is 4 gauge, so that we have the 2 powers splitting off. One will go to one Anderson connector, one to the other. Same with the grounds. And that way we can have these nice Anderson connectors, and we can outfit whatever future batteries we may have with the same connectors, and they can be quickly interchanged. These are the 175 amp units. The connector comes with, or at least the ones I bought, came with these caps. I would recommend you get them. They hook around one of the base cables so that when you don't have your battery hooked up to something, you can have a cover over it. And just for good measure, I did the same on the inverter side, so that let's say you have one battery hooked up and you're putting power and ground onto the network, you would like to have your unused connector capped. So I'll provide the link in the description. We're out here with the hammer crimper again. We're going to try for some redemption here. These Anderson plug or Anderson connector lugs are sealed all the way around. They're like a heavy lug is kind of what I meant to say. So we should have a little bit more success here. Let's see what I can get done. Nothing. Alright, maybe the rubber and the sand and the dead blow is actually working against us this time. We got our 16-ounce contractor hammer. We're just going to have to go hard with it. So let's see what happens here, and I'll try not to smash the hell out of my hand. Super disappointed with this. Alright, I spent some time. I found my baby sledge. We're going to try going this thing brute force style, see what happens. This is what I should have had all along, but it was at another property and I had to find it. And anyway, let's see what happens. Okay, so that's the trick. Don't do it with a dead blow hammer. Don't try it with a contractor's carpentry hammer. You need a mini sledge. That's just how it is. Alright, lesson learned. Okay, so we've got our first cable here that we crimped successfully. Obviously it's getting dark. I'm having to rely on some battery powered light. Passes a good pull test. Anderson connector. You'll notice that there's not really a male and a female connector. They're actually made exactly the same, and they connect a certain way. See that? All the contacts are the same, and when you put the connectors together, they just come, let's see, this rounded nub on each one come and slide together like that, and there's a metal tab pushing this connector terminal forward, and back on the back of this side there's a metal tab pushing this terminal forward, and the tension between the two can pass 175 amps. So I've never assembled one of these before. They are labeled positive, negative. I've got the red cable is the one that we terminated. We see that the flat spot on the back is here, and we want to identify where the metal is inside here. So we put the metal tab at the top. We expect the terminal to be secured at the top. We confirm which one is positive, this one. And we should be able to just, yep, there it is. So you do that. Always make sure to check your polarity, and we should be good to go. One side note, when you crimp these, you need to make sure, especially if you're using a hammer crimper, that you have this portion of the terminal parallel to the ground like this. Because when you smash this flat, you're going to have a little wing sticking off this way and a wing sticking off this way. And they need to be in line with the shape of the terminal body up here, otherwise they won't fit into the connector properly. So make sure that when you use your hammer crimper, it is crimping like this. Okay. Well, since we are actually losing daylight here, this is about the last of it we're going to see, I think. I'm going to focus on getting one battery set up. So this other second battery Anderson setup, I'm just going to put that off to the side for the time being. I just need to get some basic functionality before the sun goes down. So we take our distribution block that has a solid links in it, black cable, hook it up to the black cable on this other Anderson configuration. I've already opened up one of the screw terminals on each of these blocks. So you just pop that in there. So you can see, you just pop that guy in there, and this is just as simple as you expect it to be. It just tightens down. I do like to get kind of snug on these, not like monkey strength, but you don't want it to be too loose. Same thing on the positive side. And of course it should be pretty obvious, but when the time comes, probably later tonight, I will go ahead and set up the other Anderson connection flying leads to the other input on each of these. And then I'll have a quick disconnect for up to 2 batteries. Or if I really wanted to, I could expand the system and just use one of these interconnects as just a pass-through for a larger battery bank, or to possibly supply a different system with the same battery bank. Anyway, so distribution system going to the inverter, 2, currently just 1 connections coming in, Anderson, and then I'll outfit the battery with the other Anderson connector side, so we'll be good to go. Oh, you know what? Actually just realized I forgot to put this around one of the cables in here. So actually I'm just going to take one of these loose, slide this loop over it, and that way we'll have our cover attached. I got some 4-gauge ring terminals to go along with the cables on the individual batteries. You can see these 1/4-inch bolts work out really well. So I'm just going to drill some holes, and hopefully on the other side we will we might have to step these out a little bit, but hopefully we'll be able to make a good connection and get some light going. So let's see if I can focus in on this. There we go. Just aiming for this flat spot. Nothing special here. A small titanium bit, and I've got a titanium stepper bit. So this way. Okay, let's try this with a bigger drill that can spin faster. Nope. Wow, this copper is a lot harder to drill through than I actually expected. That's unfortunate. Alright, here's the deal. These batteries are now matched and their total voltage, and they should be ready to be connected together. The problem is I can't drill through this copper. I really thought it was going to be a lot easier than apparently it is. I used a regular cheap set of bits. I used titanium bit. I just can't seem to drill it. So the sun's about out, going down. And so what I'm going to do just for tonight to get the inverter functional is just use some of those huge drill bits I had earlier, or maybe if I can find something more appropriate, to connect in parallel these batteries, and then I can use the fused output that I've generated with this set of cables and connections so that I can safely run the inverter. We should be good to go. So I'm going to get to work quickly. This is just going to be mashed together. I think it's about 8 o'clock, something like that. So that means we've been out of power for about 9 or 10 hours. So hopefully this will be the last day of this, but I'd like to have some lights. So I'll be back. Alright, inverter's out of the box. All the connections are at the bottom. And clear. Yep, and we can go ahead and make our connections to our batteries. That's positive and negative there. You've got your AC out and your AC in over here, because this is potentially tied to a wall outlet or something and can be an automatic transfer switch for you. And then you've got your solar panel connections. So I'm just going to go ahead and hook up our battery, and I've got the switch off. Make sure you've got it off when you hook anything up, and we'll see what happens. A note for you guys, don't use 1/0 cable. It's too big. The ring terminal does not fit through the passageway, you can see. So I've had to disconnect my main leads and actually fish them through this opening here in the box and pull them through this way so that I can then mate to the terminals here. But yeah, don't use 1/0, stick to 2-gauge. On the other hand, if you do go through this struggle because you chose 1/0 cable, it's actually almost like a nice seal here with these silicone boots. Alright, so we've got our hillbilly set up here. The masonry bit joining the negative terminals there, clamp on either one. Paddle bit here making the positive connection, and going to our cables, I've placed the ring terminals right against the flat of the copper as they were intended to be, just for obvious reasons. Okay, so that comes out to our Anderson connector. That Anderson connector goes to the inverter. In the future, this block will branch out to another set of Andersons, and the batteries will be independent instead of what you see here. When I put this Anderson together, there was a pretty good sized spark. So hopefully everything's okay. It might just be charging the capacitors in there. It's pretty good sized spark though. Here's your line out. You see there's a diagram there, ground, line, neutral. So let's see what happens. Okay, so I guess we've got 24 volts. Saw the fans kick on for a second there. I'm gonna guess that the circuit board is happy. I don't see any error messages anyway. Alright, I think we might be in business. Let me play around with this for a minute. I didn't touch anything. Just a couple seconds after I stopped recording that last little segment, the screen developed into what looks like an AC output. I can see the AGM battery is selected. I'll go in there and change that to lithium ion. But it looks like our output may be live. So I have got a little cordless drill charger here. It has a status light on it. Comes on a couple seconds after it's applied to AC current. So let's see if we actually have an output. Look at that. AC power. Okay. So now I can keep my food and maybe even turn the TV on for a little bit. But obviously I'm going to go in there and configure this so that the battery cutoff shuts off to keep the cells safe, especially because I don't have a BMS applied yet. But yeah, check it out. We got power. I'm going to run an extension cord to my fridge and cell phone charger and sleep well tonight.
It is currently 2 o'clock in the morning. I just did a 4-hour round trip drive to Carroll, Iowa. I didn't know it existed either. Don't worry about it. But I got this pretty decent generator. Briggs & Stratton motor on it. Getting something bigger and knowing that I'm not going to be able to pass more power through it is not a benefit. This way I can make gas last longer, and I can allow the inverter to act just like it's supposed to as an automatic transfer switch. When it has excess power, which it will practically all the time, it will charge the batteries with this generator so that I don't have to be running a generator all the time. I can just charge the batteries, and once they're charged, I can switch the generator off and make the best out of every little bit of the little gasoline that I have in this 2.5-gallon container.
And just like before, we followed the little diagram over here. We've got ground, line, neutral, in the same order as the one below it. The only difference is we've now got a male inlet plug that we can apply grid power with. I gotta tell you, generators became commodities real quick today, like practically instantaneously. So that's why it was so hard to find one. All the stores are sold out. Everybody on Facebook Marketplace, Craigslist, everybody had already sold what they had. So realistically, this is something you need to plan for if you have a small solar system that cannot be powered entirely off of solar. It's just the reality of things. So let's hope this thing works. I see the fuel control valve has been broken off. That's too bad. Right there, there's supposed to be a little handle. Okay, well, let's see if it goes. Well, we found our first configurable that needs to be changed. 28 amps is what we were getting. The way to change that is to find your maximum utility charging current setting. This device is capable of 60 amps. So, whoops, there it is. So we go to item 13, as we see here, and I'm going to select this, change it to, don't want down, change it to 60 amps, enter. Okay. The fans definitely pick up speed. So let's take a look and see how much we're actually getting to the battery now. Look at that. 59, 61, 62 amps. There we go. Now we're charging. We're really using that generator now.
It's a few weeks later. Power is back on. Everything's fine. I just wanted to give you a little update. You guys only saw my, hey, it's working, I'm going to go charge my phone. But actually, these batteries and that 2400 watt inverter did a great job. It kept me comfortable when the power was out for days and days. Ran 2 air conditioning units, my refrigerator, and a almost 300 watt TV. No problem at all. Did a great job. No complaints whatsoever about the batteries. The inverter I liked a lot. I do wish that when you set the charge current, which is what's actually going back to the batteries here, I wish that when you set that maximum charge current, it was handled as a true maximum. And what I mean by that is, when you set 60 amps, which is the maximum charge current, it's going to charge at 60 amps. It's not variable. It will charge at 60 amps independent of what your other AC loads are coming out of your generator. And it can very easily overrun the one leg of the generator that you're running. I had that problem a lot. It was kicking in and out. Instead of running off of the generator just couldn't support that much load off of one leg. So it would kick over to battery power, which meant that my generator was running for no reason. Anyway, that's my one criticism of the inverter, but the system worked great, kept me comfortable. Power was out for almost a week. Some areas of central Iowa were out for over a week. So this was a real game changer for sure. And I hope that we all learned something, and I'll put together a video later of the Ant BMS system that I've got. You'll notice that I actually have ordered the correct adapter cables here for the balance leads to go to the Molex connector that's inside this cover on each of these batteries. So I'll put together a video later showing how I configured those. You can find all kinds of videos about BMSs being applied to these batteries. I just wanted the best functionality out of a BMS with the best battery I could get for the money, and that's what I'm going to try to show you guys later. It's also worth noting that in the process of doing this and putting all these little video clips together, I've decided to convert my YouTube channel that's God knows how old. It was just used for private, personal stuff, but I've collected a few viewers, or subscribers I should say, so I've actually converted this to something. We're going to do all kinds of fun stuff like this that is user submitted. So you guys go ahead and suggest what you'd like to see. Any myths you want busted, any small projects that I can put together and do a little demo for you in the backyard or something, just, make a suggestion, send me a message, and we'll see what comes up. Have fun.